Okay, so first kind of load what we have. So today we are going to discuss on loading. So from today for the next 5 sessions, we are only going to focus on loading and discuss each and every load in detail. Today we will be focusing on dead load, live load and wind load. But start from first. First one is our dead load. So what is dead load? First, an important category which will come under dead load is the self weight of your structure. Your structure will have certain self weight. Then you will have weight of structure which you have not modeled, right? When it comes to self load, what will be the self load? Self load will be the load of your structure. Right now, if this is your structure, this is your framing, whatever would be the self weight of these structure, that would be considered as dead load, that would be considered as self weight of your structure. But remember, we have not modeled everything. Many There are many parameters which we have not modeled. Tell me the things what we have modeled. I'll explain first modeled and then not modeled. Modeled and then not modeled. We have modeled column, that load will be there. We have modeled rafter, we have modeled purlin, and we have modeled bracing. On your warehouse, what will be there apart from this? First, you will have your cladding. What is cladding? Cladding is sheeting above your purlins. There will be certain covering that is called as cladding, sheeting, that we have not modeled. Second thing, in this structure, what we have not modeled is girts. Third thing, what we have not modeled is we have not modeled the connections. Yes, for the connections there will be certain gusset plates, there will be certain clit angles, there will be bolting, there will be welding. So these all additional members we have not modeled. There will be splicing. Fourth thing, what we have not modeled, maybe your structure you want to use it for solar panels. So there might be certain solar panels on top of your roof. That solar panels we have not modeled, or maybe any structure, any machinery on roof or on structure in general. So these are all the things what we have not modeled, and there could be many more. Okay, so this weight we have already considered. This weight also we need to consider in our dead load. Okay, in case of mezzanine, yes, the weight of the flooring, that we have not considered. All other parameters, I hope it's clear to all of you. Now this is my Excel. I've been sharing this Excel since our first session when we started with the modeling part. In the modeling part, the geometry parameters was important. The length of your structure, the width, the height of the roof, the degree of inclination, and number of bay in X and Z direction, column spacing, purlin spacing. So these all were the geometric parameters. Next important thing what we have here is the dead load. First thing what comes under dead load is the self weight of the structure. Okay, now here we have the factor of self weight as 1.1. This additional zero point 0.1 is because of the weight of the connection. What we assume, let me explain you. Now coming to our first load. Our first load case is self weight. Our first dead load is self weight and we have factor of 1.1. What is this 1? 1 will be the weight of the structure plus 0.1. What is 0.1? You can also represent this 0.1 as 10%. weight, or you can write this 10% weight as 0.1. This 10% weight is weight of connection. So we say that whatever is my weight of the structure, additional 10% would be the weight of my connection. That is the reason in self weight I am considering 1.1. So if I consider 1.1, in this structural weight as well as connection weight is considered. So dead weight of structure as well as dead weight of connection is considered. Is this point clear to all of you? Tell me the point of self weight is clear to all of you or no. Did you understand why we take the factor as 1.1? Now I will let you know how you can assign this value. Okay, this is my structure. Whenever I am assigning any kind of loading in STAAD Pro, specifically in a warehouse, I will go in definition specifically for dead load. I will go in reference load, and in reference load definition, I will create add. Here I will write ref dead load DL. Okay, and I'll click on add. If you want in loading type, you can choose as dead. Even if you don't choose this, it is fine, but yes, you can choose it. Ref dead load add. Understood? If you are in support, go in loading, click on definition, click on reference load definition, and then click on add, and then write ref dead load and choose the category as dead. Close. Then this category of dead load is created. Now in this, again choose ref dead load, click on add. When you click on add, you will have list of loading available over here. The first option is self weight. In this self weight, you need to assign direction as y, because we want to assign self weight in gravity direction, and the value would be minus 1.1. We are that 10% would be additional weight of connection. This depending structure to structure, you can say that in my structure, I will be having maybe 20% of weight of connection. So you can write 1.2. Maybe you will have, I will have 15% of weight of connection. You can write 1.15. Or I will say this is my normal structure. I will have only 5% of the weight. So you can just write 1.05. Okay. So in this way, the additional 0.1% or 0.2% or 0.15%, this depends on type of structure. But in general, you can say 10% would be the weight of my connection. Is my voice clear to all of you? Am I audible to all of you? Okay, it's clear now. So let's continue. I hope self weight is clear to all of you. In self weight, generally we assume that 10% would be the additional weight due to the weight of the connection. So that is the reason we write 1.1 as the self weight factor. This factor I have shown over here. In STAAD window, you can see in factor I am writing minus 1.1 and I click add. So here self weight is getting added. This 0.1 is the additional weight of the connections. Depending on type of structure, this can be 20% or 15% or maybe just 5%. So this will depend on structure to structure. But in general, when you are working on any kind of warehouse, you can start with 10%. So you can say 10% would be the weight of my connection. Yes, this is empirical. This is just by experience. When you work on various projects, you will understand that by experience, 10% is generally the weight of the connections. Okay, the next thing after this, what we have is the weight of the cladding. Now, what is cladding? Cladding is the roof coverage on top of your structure. Okay, so let me show you cladding. Now this is your structure. Of course you will have your cladding on top of the structure, right? So what I am doing for this cladding, I don't know what will be the weight of my cladding, what will be the weight of my uh, metal sheet, what will be the weight of my sheeting above the structure. So for that we have one code, is code. If you are using any particular brand, any particular company's sheet, that data sheet will give you the detail, but you also have a code. Let me show you. is 875 part 1. This code is 875 part 1 is generally used when you want to check the details of loading. Okay, when you scroll down in this, for various kind of loadings you have this table, and you can refer this table and try to find what is your loading. Now in my case, I am interested in metal sheeting, perforated galvanized sheeting, plain corrugated sheeting. So in my case, I will be using class 1, and whatever is the structure, maybe I'm using 0.63 thickness, and here you can see the details are given, and the weight is given in kilonewton, or here it is given in kg. So if you see, it is 5.7 kg, very small value, 5.7 kg. So this I will just write in my Excel. If you go in my Excel, self weight of the structure factor is 1.1. Mezzanine floor, right now I do not have any mezzanine floor, so this is blank. Weight of sheeting 5.7 kg per square meter. So it will become 0.057 kg per meter square, kilonewton per meter square. Okay, so this you will convert into UDL on your purlin, and that will be 0.095. How I have written this value? Let me just quickly show you. See, these are my, okay, these are my purlins. I'm drawing few purlins, and on these purlins I am having my sheet. I'm drawing a cutout of the sheet. I'm just drawing a cutout of the sheet in this way. This in this sheet my purlins are fixed. Maybe they are riveted like this. Okay, so just let's remove this rivet. Now what I want to do, this weight of my sheeting, I know it is maybe 5.7 kg per meter square. But I have not modeled my sheeting. I want to apply this as UDL on my purlin. I want to apply like this, UDL on my purlin. So what I will do, half the load of this and half the load of remaining this much loading will be transferred to my purlin in the form of UDL like this. So to get this UDL, what I will do, I will multiply 5.7 into spacing between my purlins. So this is spacing by 2, this is spacing by 2. And what is spacing? Spacing between my two purlins. So if I multiply this by spacings, I will get UDL on my purlin. In this way, in the Excel, automatically I will get my value of UDL as 0.095. Okay, kilonewton per meter. Weight of suspendable walkables, I am not having any kind of suspendable walkables, means. Next I have weight of solar panel. Let us assume that this structure will have also solar panels on top of them. How? Let me show you. If this is my structure, the client is planning to also install solar panels on my structure. So how he will do that? This is my structure. First thing what he will do, he will install the cladding. Let us assume this blue part will be the cladding. He will install this cladding. I'm only drawing one side. Above this cladding, he will call the solar panel company, and then he will also install this, maybe this kind of panels, this kind of panels, solar panels. Yes, like these, there will be solar panels all over the roof. So this weight of solar panel, that will also be given by the company who is installing the solar panel. Let us assume it is 20 kg per meter square. Again, this will be converted into UDL on purlin. How I'll convert? I'll multiply this 20 with spacing. Then I will get UDL on my purlin. Okay. So this is a simple method through which I get UDL on my purlin as 0.335, and this is the end purlin. Okay. So let me show you how you can apply these loading on your model. So this is my model. I will click on reference dead load. I will click on add. I will go in member load. Here I can apply UDL, kilonewton per meter. So I'll write minus. I'll go in Excel and I'll see what is the value. 0.095. 0.095 kilonewton per meter in gravity y direction. Click on add. Next one, for my solar panel it is 0.335. So I'll write minus 0.335 and again I'll click on add. Now let me explain you why I have these additional blue values over here. They are half of the original value. So let me explain you that point. I'll explain you here itself. Maybe see, for these purlins you will have load from both the sides. For these purlins you will have load from both the sides. But for the end purlins, this one, you are only having load from one side. So why you want to multiply it by both the sides? So here you will only multiply by this half distance, that is S by 2. For central, it is on both the sides. So it is S. So that is the reason for all the central ones, we will take total UDL, and for end ones, we will take half UDL. How you will get half UDL? The value is written over here. First one is 0.048. So minus 0.048. Click on add. 0.168. Minus 0.168. Again click on add. Now I have added these values, but you can see a question mark is written over here. The question mark is because I have added these values, but I have not applied it on my members. So I want to apply it. Yes, Excel sheet would be shared with you. Okay, so self weight of the structure. First click on self weight of the structure, assign to view. Click on assign to view, click on assign and click yes. So your whole structure will be assigned with self weight. Now coming to these values, we want to assign these values only on purlin. So go and select, go in group. We want to select all the purlins. Say right click, new, not labels, right click, new view, enter. So right now I am able to see only my purlins. So I'll apply the load on my purlins. How to apply? Again, open definition, reference load, dead load definition. So this one I will apply on internal purlins. I will not apply on end purlins. So I'll choose them. Assign to selected beam, assign, yes. Again for second one, assign, yes. For third and fourth, I told you these are only for the end purlins. So I'm assigning it only to the end purlins. Assign, yes. Fourth one, assign, yes. Now you can see all the four loads have been assigned.
Hello everyone, welcome you all in an ISO certified live training program, design of steel structures with connections by using STAAD Pro, IDEA Static and Advanced Excel. This training program is going to cover everything from basic to advanced for STAAD Pro and IDEA Statica. Integration of conceptual studies with manual and software approach. Steel beams, columns, frames and truss elements designed by the STAAD Pro. Analysis and design of all types of connections by using IDEA Statica. All steel structural elements along with the connection design by using advanced Excel sheets. With all of this study, we are going to cover 4 real example projects in this training program. Analysis and design of steel warehouse along with the connections. analysis and design of pre-engineering building structures along with the connections, analysis and design of steel buildings along with the connections, and in the last we are going to take analysis and design of infrastructure as truss and trussel assembly by using STAAD Pro. Along with all of these studies, we are also going to see how to prepare the final design sheets for the site execution. Have a look over the features of this training. Daily live classes conducted by expert for 1.5 hours. Recording of every session with lifetime access. Can interact with expert anytime, 24/7. Exposure to real practice. ISO certification of training completion. It's 5-star rated training program. Till now more than 2000 participants have benefited from this training program. Now you are the next.